Hello everybody, this is BBoss1997 speaking, and welcome back to my channel. In this video I'd like to discuss devices called capacitors. My goal in this video is to give you a basic understanding of what they are, some of their uses, and how they work. I'm not going to get into all the math of their operation simply because math does have that tendency of confusing people, including me, so I'm not really going to get into the math. Basically what I'm going to do is I'm just going to show you the basics of what they are. So, before I begin describing exactly what they are and how they work, I'm going to draw you the circuit diagram, because I believe that the circuit diagram gives a great clue on how they work. Here is the circuit diagram for a capacitor. It's just two lines with a space in the middle with two conductors on either side. Now, the reason this is so useful in determining how they work is because that's all a capacitor is. There is a conductor plate, another one, with dielectric in the middle. What a dielectric is any fluid, gas, or solid. Capacitors can use either one of those, solid, liquid, or gas, that does not conduct electricity. Oil is an example of one. It's not always called dielectric, but with capacitors and batteries, it typically is. Now, when you apply a positive charge to the capacitor, electrons flow this way into it, if this is applying the positive charge. Now, because there's a dielectric in the middle, charge can't flow through the capacitor, but they can flow into it. So here's what happens. When you apply positive charge, the electrons flow this way into it, and they build up on this side of the dielectric. But of course, like I said before, they can't pass through it. It gets to the point where you can't force any more, where you cannot force any more electrons into it. When that happens, it's charged to its capacity. That's why it's called a capacitor. It has capacity to store charge. So when we take the charge off, when there's no more current going into it, these electrons are still here because they don't know where to go because of the dielectric. But say we bridge the gap here. We bridge the gap, all the stored electrons flow out of the capacitor this way, and into the negative side. Now the capacitor has been balanced. There's no more electrons on this side, because you know how Mother Nature hates imbalances. So these electrons want to flow to the least concentration. Same thing with get into chemistry, same thing with solutions, but we won't talk about that here. So that's all it is. It's a very simple device that stores charge. Now, the capacitor has so many uses, it's not even funny how many uses they have, but I'm only going to discuss a few. Use A. If you have a disposable camera, or any camera, to be honest, you'll know that it has a flash. Here's the basics of a flash circuit. We have a battery. We have a capacitor. And we have a flash tube. Oh, and a switch. Here's how it works. Just going to finish drawing the diagram here. Whatever. Doesn't look too good, but who cares? Okay, so we have a battery that charges up the capacitor here to around 200 or 300, 400 volts, around that range. Medium voltage, I'd call it. So all these electrons are stored up in this side of the dielectric. Now it's only when we complete the circuit that they all discharge into the flash tube at the same time. Because the flash tube is filled with an ionizing gas, it releases a very bright flash. Now this is utilizing their discharge property. Capacitors are different from batteries in that while batteries release their charge slowly over a period of time, capacitors release it all at once in a burst or a pulse. You could not power a flash tube with a battery because all it would do, if you had the voltage high enough, would arc inside the tube. We want a burst to energize those electrons. that's one use. Now another use B, let's call it, is utilizing their smoothing capabilities. Before we discuss that, in part 1 of this video, this is going to be part 1, there's going to be a second part where we look at what they actually look like. We're going to discuss, right now, let's just talk about power rectification. If you have an AC signal, it looks like this. This is AC, alternating current. This is positive, this is negative. So it alternates between positive and negative. In the US, it is 60 cycles per second. When you have a diode, and what a diode is this. A diode lets current flow in only one direction. So if we apply AC to this, it'll let it flow this way, making this the positive side, but it won't let it flow this way. So basically it rectifies it into DC, but what we call that is half-wave DC. Half-wave DC looks like this. All a rectifier does, or all a diode does, is remove this negative side. So now we have this. Sort of like a Loch Ness Monster. That's what I'd refer to. So we have positive, and it won't let it flow back. So that would be our negative side. Now this would be fine, assuming you're not going to hook up like electronics to it, or a battery. For that we need smooth signals. So what a capacitor does is it takes this half-wave DC and turns it into smooth DC. This kind of capacitor called a smoothing capacitor. And how this works is when we have this goes into the capacitor and charges it up. So the capacitor is fully charged. But when we have this drop off here where there's no current, the capacitor actually releases some of the current to compensate for the lack of current or the imbalance. So it's constantly charging and discharging at 60 cycles per second, producing a smooth signal. An analogy would be a flywheel on an engine. So say we have an internal combustion engine here, and it's hooked up to, why don't we say, it's a weird example, but why don't we hook it up to a meat grinder? Okay. Just a weird thing that doesn't act as its own flywheel. So if we hook it up to a meat grinder, you know how a combustion engine operates by the pistons going up and down. If we didn't have a flywheel, those movements would be extremely jerky. It would be like, and this meat grinder wouldn't be as efficient as it is because it's not moving smoothly. So this meat grinder would be just grinding meat, but it would vibrate a lot. But what a flywheel does is once you get that flywheel spinning, it has a lot of stored energy. So, like I said, the engine releases its energy in bursts. But when you attach a flywheel, the bursts get the flywheel spinning, but when there's no energy coming from this engine because it moves in bursts, like I said, the flywheel is the one that turns the meat grinder or whatever you want to be on this end. So the flywheel is constantly charging and discharging, just like a capacitor. It smooths out the energy output from this engine, just like a capacitor would in an electrical power supply. Now, that's the end of part 1 of this video. I hope you enjoyed, and we'll get to part 2. I'll make part 2 in a couple minutes once this video is done uploading. So, I hope you enjoyed. This is the basic principles of the capacitor's operation, some analogy, and in part 2, I'll show you some examples. So, I hope you enjoyed this video. I hope it was informative. So, this is B-Boss signing off.